Welcome back to the Science of SKB. Part 2. Discovery of the atom and its parts, periodic table, the first 20 elements, nuclear notation, and electronic configuration. Democritus in 400 BCE proposed the idea of the atom as an indivisible particle that makes up all matter. He provided no experimental evidence because it was purely philosophical. Now, Dalton in 1803 developed the atomic theory, stating that matter is composed of indivisible atoms. Atoms of a given element are identical, and that atoms combine in simple whole number ratios to form compounds. His ideas were based on experimental evidence. Thomson in 1897 discovered the electron using the cathode ray tube experiment, and he proposed the plum pudding model where electrons are embedded in a positive soup. Rutherford in 1911 discovered the nucleus through the gold foil experiment. He also proposed that the atom has a dense, positively charged nucleus surrounded by electrons in empty space. From there, he came up with the planetary model of the atom, and he overturned Thomson's model. Bohr proposed the Bohr model, where electrons orbit the nucleus in fixed energy level. He built upon Rutherford's model and explained atomic spectra. Chadwick in 1932 discovered the neutron, a neutral particle in the nucleus. This discovery completed the understanding of the atomic nucleus. This timeline reflects how our understanding of the atom evolved over centuries. This table reflects the location, charge, and mass of each subatomic particle. Protons and neutrons are found in the nucleus. Protons have a charge of +1 and a mass of 1, while the neutron has no charge and has a mass of 1. The electron, which is found in the orbital, has a charge of -1 and negligible mass. The periodic table is a chart that organizes all the different types of atoms called elements. The modern periodic table was developed by Dmitry Mendeleev in 1869, who arranged elements by increasing atomic mass and predicted properties of undiscovered elements. His observations made the periodic table what it is today. He even left gaps wherever the order of his classification suggested an element should exist there, even though it was not known. Amazingly enough, he correctly predicted the properties of these missing elements. Of course, with every discovery, there are imperfections in that some of the atomic masses of some elements did not fit the pattern. These problems were later cleared up by Henry Moseley in 1913. Today, the table is arranged by atomic number thanks to Moseley's work. However, credit is given to Mendeleev for the periodic table. The periodic table displays 118 elements. 92 of the elements occur naturally here on Earth. The rest are man-made. The elements in the chart can be categorized as either metals, metalloids, nonmetals. The metals are further categorized as alkali earth metals, alkaline earth metals, transition metals, rare earth metals, radioactive metals. Well, the metals aluminum, gallium, indium, tin, thallium, lead, bismuth, polonium, nihonium, flerovium, moscovium, and livermorium do not fall under any particular category and are referred to as post-transition metals or other metals. The periodic table organizes elements into rows and columns to highlight patterns and relationships among them. It has 7 rows, which are referred to as periods. Each period corresponds to the number of orbitals that each element in the row has. Anything found in row 1 would have 1 orbital. Anything found in row 2 would have 2 orbitals. Row 3, 3 orbitals, and so forth and so forth. The lanthanide series is a part of period 6. It fits between barium and hafnium, while the actinide series is a part of period 7 that fits between radium and rutherfordium. They are part of the actual periodic table but have been placed at the bottom to condense the chart due to the need for space within textbooks. There are 18 columns in the table. They are referred to as groups. Groups refer to how many valence electrons there are in each of the elements that are within the group. Valence electrons are electrons that are located in the outermost shell of an atom. Group 1 is referred to as the alkali earth metals. Group 2 is referred to as the alkaline earth metals. Group 17, which is also referred to as Group 7 when the transition metals are ignored, is referred to as the halogens. Group 18, which is also referred to as Group 8 when the transition metals are ignored, is referred to as the noble gases. The size of the atoms increase going down the group due to electron-electron repulsion, but decreases going across the period from left to right due to increasing nuclear charge. Francium is a group 1 element. It is the most metallic element on the periodic table. Fluorine is in group 17 or group 7 if the transition metals are ignored. It is the most electronegative element. This simply means that it has the strongest ability to attract electrons out of all of the other elements when it forms bonds with other elements. Hydrogen is a group 1 element. It is the only non-metal within the group. It is a special element because it is sometimes placed by itself on the periodic table. This is because it only has 1 orbital, and that orbital can only hold a maximum of 2 electrons. When hydrogen has 1 electron in its valence shell, which is its only orbital, it is placed in group 1. When hydrogen has 2 electrons in its valence shell, it is placed in group 18 or 8 if the transition metals are ignored. This happens when it forms the molecule hydrogen gas, which is H2. When hydrogen accepts an electron to form a bond with a metal or another element, it behaves like a group 7 element. For example, when it reacts with sodium to form sodium hydride. At this point, it is referred to as a hydride. Helium is also a special element. It only has 1 orbital, which contains 2 electrons. This shell is helium's valence shell. The first orbital can only hold a maximum of 2 electrons. This means that helium has achieved a complete duplet. is in group 18 or 8 if you ignore the transition metals, because all of the other elements in that group have filled their outer shells and they share similar properties. Carbon is in group 14 or 4 if the transition metals are ignored. It is ubiquitous in nature. This simply means that it can be found everywhere in nature. You are required to learn the first 20 elements of the periodic table: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. Each element has a mass number A, an atomic number Z, and a symbol X. The mass number A refers to the total number of protons and neutrons that are present within the nucleus, where the mass number is equal to the number of protons plus number of neutrons. The atomic number Z refers to the total number of protons that are present within the element. It also indicates the position of the element in the periodic table and the amount of electrons that are present within the element when it is neutral. The symbol X of the element is its identity. Writing information about the element in this way is referred to as nuclear notation. Take, for example, magnesium. Magnesium has a mass number of 24. It has 12 protons and 12 neutrons. It also has 12 electrons, and it is in the 12th position on the periodic table. From the periodic table, we can see that magnesium is indeed in position 12. Additionally, the periodic table reveals that magnesium is in group 2 and period 3. This means that magnesium has 2 valence electrons in its outermost shell and has 3 energy levels. We can obtain the same information by drawing out the arrangement of the electrons for magnesium to determine its electronic configuration. Here are some key things we need to know before drawing out the arrangement of the electrons for any element to determine its electronic configuration. Energy level number 1 holds a maximum of 2 electrons. Energy level number 2 holds a maximum of 8. Energy level number 3 holds a maximum of 8. And energy level number 4 holds a maximum of 18. First, we start by drawing the nucleus. Then we fill it with the identity and the number of protons. From there, given the mass number, we can determine the number of neutrons that will be inside of the nucleus, where mass number is equal to number of protons plus number of neutrons. Therefore, the number of neutrons will be equal to the mass number minus the number of the protons. This will give us 24 minus 12, which is equal to 12 neutrons. We fit that right into the nucleus. Then we draw our first energy level. We subtract 2 electrons from how many electrons we have, and we find that we have 10 more electrons to play with. Once we fill the energy level with the 2 electrons at the 12 and the 6 o'clock position, we can move on to filling out the second energy level because the first energy level is complete. It can only hold a maximum of 2 electrons. Yay! So now we're moving on to the second energy level, and we see that from our calculations, we have 10 more electrons to play with. The second energy level, according to the table, can only hold a maximum of 8. We definitely have 8 electrons that we can fit into that second energy level. When we are filling out our energy levels, we want to put our electrons at the 12, 3, 6, and 9 o'clock position, one by one. So if we start with the first 4, nice, we have that filled, and then we fill in the second 4, and now we have 4 pairs of electrons. Now that that energy level has been filled, we have to move on to the third energy level. According to our calculations, we have 2 more electrons left. Once we fill out that third energy level, we have no more electrons left. And because we have 2 electrons, we fill that third energy level at the 12 and the 6 o'clock position. There you have it. Shell 1 has 2 electrons, shell 2 has 8 electrons, and shell 3 has 2 electrons. Hence, the electronic configuration for magnesium is 2.8.2 or 2:8:2 or 2,8,2. You can write it in any of these formations. The 3 digits 2, 8, 2 indicate that there are 3 energy levels, and the last digit indicates the group that the element is in, as well as how many valence electrons it has. So according to the electronic configuration of magnesium, magnesium is in period 3, group 2. It has 2 valence electrons and is in the 12th position of the periodic table. Let's try some more elements. So here we have hydrogen. Then we have helium. Once we approach helium, the first energy level has been fulfilled. So therefore, the next element will start the next period. There we go. We have lithium. And as we move along, you'll see that the shells are slowly filling up. Then beryllium, which is in the 4th position. Then we have boron in the 5th position. Carbon is in the 6th position. Nitrogen in the 7th position. Oxygen is in the 8th position. Fluorine is in the 9th position. And neon is in the 10th position. If you look at that energy level, it is completely filled. It's maxed out. So neon ends this period, and we're going to start with a whole new period. So now we're in period 3 with sodium in the 11th position. Then we have magnesium in the 12th position. Aluminum in the 13th position. Silicon in the 14th position. Phosphorus in the 15th position. Sulfur is in the 16th position. Chlorine is in the 17th position. And now that we've reached the 18th position, we see that the third energy level is completely filled. And now that ends this period. Argon ends this period, and we're now moving on to potassium, which is in the 19th position. And finally, the last one that we're going to focus on will be calcium in the 20th position. All right, so we made it to comprehension. Given the names below, place them next to the statement that corresponds to them. We have Dalton, Democritus, Thomson, Rutherford, Chadwick, Bohr, Mendeleev, and Moseley. Read the information in the table and fill it out accordingly. Do you have these answers in the same order? Congratulations! The first one speaks about Dalton. He developed the atomic theory. Rutherford discovered the nucleus via the gold foil experiment. Democritus proposed the idea of the atom as an indivisible particle that makes up all of matter, while Thomson proposed the plum pudding model. Bohr proposed the idea of energy levels. Mendeleev developed the periodic table, Chadwick discovered the neutron, and Moseley placed the elements in order of their proton number. Comprehension. How many elements are on the periodic table? How many of the elements on the periodic table are man-made? How many periods are in the periodic table? And how many groups are on the periodic table? Did you get them correct? Excellent! So there are 118 elements on the periodic table, 26 of them are man-made. You have 7 periods and 18 groups. Good job! Comprehension. Use the periodic table to indicate where the alkaline earth metals, the halogens, the noble gases, and the alkali earth metals are. Yay! I know you have it correct. Great job. So the alkali earth metals are in group 1. The alkaline earth metals are in group 2. We can find the halogens in group 17, or 7 if you ignore the transition metals. And we find the noble gases in group 18, or 8 if you ignore the transition metals. Comprehension. Use the periodic table to locate the element that is in period 7 and group 1, group 17 and period 2, group 18 and period 3, period 2 and group 2. Answer: francium is in period 7 and group 1. Fluorine is in group 17 and period 2. Argon is in group 18 and period 3. While beryllium is in period 2 and group 2. Comprehension. Use the periodic table to locate the element that is in period 4 and group 2. Draw the arrangement of the electrons and determine its electronic configuration. Best wishes! Awesome sauce. I know you have this correct. So, the element that is in period 4 and group 2 is calcium. If you draw out the arrangement of the electrons, you will find that the electronic configuration of calcium is 2882. Remember, you start from the energy level that's closest to the nucleus and you count coming outwards. Given the nuclear notation, what is the name of the element? What is its position on the periodic table? How many protons, electrons, and neutrons does it have? Draw its electron arrangement. Determine its electronic configuration. And what group and period is it in? And how many valence electrons does it have? Awesome sauce, guys and gals. I know you could do it. So the element's name is carbon. It's in position 12. It has 6 protons, 6 electrons, and 6 neutrons. We have the arrangement of the electrons on the right here, which is correct. And that gives us the electronic configuration of 2.4. It's in group 14, or group 4 if we ignore the transition elements, and the period 2. And it has 4 valence electrons. Now note well, ignoring the transition metals makes it very easy to answer the questions when it comes to valence electron count, group numbers, and all that jazz. I hope you enjoyed part 2 of Investigating Matter. See you for part 3. Bye!